Hello and welcome to the next installation of my Michelin Mission series. Today we are down here at the Koenigsegg factory to give you an insight into, first of all, their latest hypercar, the JESKO. We're also going to be taking a look at how Koenigsegg prepare for their big launches before the Geneva Motor Show. It's also a reason why I'm wearing my sexy new Koenigsegg trousers. Let's head inside. Here we are, welcome to Koenigsegg, honoured to be here. I'm back with Christian von Koenigsegg. I want to start by acknowledging the name of this project, because not only is the car itself incredibly substantial, run us through the background of the name.
I mean, it's my father's name, JESKO. Sure. So, I mean, he's been instrumental, especially in the early days, kind of helping me out when I was a young kid. I was 22 when I started. So he came on board like 1.5 years after. He kind of thought I was a little bit crazy. Wanted to build a car. I mean, he knew I was passionate about it and that I had an entrepreneurial spirit as I started my first company when I was 19. But he still thought that this is a bit of a crazy undertaking. But after 1.5 years, he actually sold the company he was involved in, and he said it would be really fun working together, and that suited me perfect because, well, I needed help, and the money I had to scrape together to do this kind of were running out. So he said, I'll come on board for like 6 months, give you a little bridge loan, and then we'll see what happens. And what happened was that 5 years later, we were working day and night, shoulder to shoulder. We had emptied all his coffers, and my mother was crazy and mortgaged the house and everything. And that really helped us come over the hump kind of to the next step, and he could retire and eventually could regain some of his investments as well.
So as of filming this, Christian's dad doesn't know that the car's going to be named after him. So when you unveil it on
That's
Geneva,
the idea. We hope we can keep it a secret until then, and we only have 5-6 days left. So it's looking good. I just don't want him to fall over, you know. So
when you pull off the covers, make sure there's a chair available. I'm going to stress now, I've just been through the presentation. This is not a facelift. This is a radical new car.
Yes, I would say so. The Agera RS turned out to be, in a way more popular than we had anticipated. It was kind of the last hurrah to the Agera range. And the Agera range started in like 2010, 2009, they were introduced the first time. And it just kept on growing in capability and in popularity, and in the end it became the world's fastest car on a public road and ever produced, and still is. But we decided to only make 25 as a limited edition, and that sold out extremely quickly, and a lot of people were like, I didn't get one, and this and that. So we were thinking, I mean, the Regera is amazing in its own right, and it's this technological marvel and unique driving experience. You've tried it yourself, but we thought, let's continue the spiritual. We need a spiritual processor from the Agera RS. So a straightforward car, as lightweight as possible. It's probably the last ever Koenigsegg not to be hybridized or like full electric or something like that. And if you compare the Regera and the JESKO, I mean, the Regera has that instant, immediate electric torque whenever, wherever, as soon as you think about it. This is as responsive as a combustion engine can be with our new pressurized response system and super lightweight 180-degree crank and super fast shifting 9-speed gearbox. But of course, it's a different experience. It's more the traditional experience, but it's lighter. Two different experiences. One is more track focused, and one is more like the ultimate road expression. So we think they balance each other out well. And we couldn't just resist it when one of our engineers came up with this kind of threw out this idea. I have an idea for a gearbox, and this engineer has been working with me for 20 years, and is just a genius. And he said, I have this idea for this gearbox. And okay, we started, wow, this is very interesting. It's kind of a simplification of what's out there. It makes a DCT look old school
and big.
Big, exactly. This is less parts and does more. Wow, why hasn't anyone done this before? And we started looking at it from every angle, and we couldn't kill the idea. And so this is perfect for the Agera RS replacement.
I mean, looking in the back of this and being familiar with how the internals of the Regera looked.
Right.
I mean, you've been able to move it so much more central. It's lighter, it's smaller. It's around about 90 kilograms for this gearbox unit.
If you take the Agera RS transmission, it's a 7-speed AMT with a helper clutch and an E-diff we developed for it. So 7 speeds, it's actually capable of 1500 Newton meters of torque, which is extreme. And that's the main reason why we used it, because the DCTs out there, they're usually limited to like 900 Newton meters or something like that, and they're bigger and heavier. So we sacrificed some shifting speed for durability, torque capability, and lightweight. And that gearbox weighed about 80 kilos, which is about 40 kilos lighter than a weaker DCT with 7 speeds. This gearbox is 90 kilos with 9 speeds, but it is in a way lighter because the flywheel and clutches are inside the gearbox, not outside. And the starter motor is also inside the gearbox. So if you take those things into account, it's probably a kilo or two lighter than the 7-speed AMT, and much, much lighter than any DCT with much less torque capability and fewer gears. How can this even be possible?
Yeah, that is bonkers.
So the whole principle is built on kind of the principle of a derailing system on a bicycle, where you're compounding gears. Instead of having like 2 gear sets for each gear, we're having 3 axles and fewer gears, and then we're stacking them up in 3 pairs instead of 2 pairs. And we can do that in various forms and shapes. So with fewer gears, we get more gear ratios. And with fewer gears, we can have bigger, stronger gears that are heavier in themselves and stronger, but as there are fewer, the gearbox becomes lighter and smaller. So kind of that's the basic principle.
And so off the back of that, you've managed to develop a function in the car where you can access maximum performance.
Exactly. So this is the first time we have a gear lever in a robotized gearbox. We always thought it's enough with the paddles, because you can go neutral, reverse, drive, everything with the paddles. You don't need anything on the center console like many other cars have. But here we felt a need, because if you're driving on a racetrack, you would normally want to go through the gears when you're engine braking into the corner, accelerating out of the corner. You want to use the perfect rev range all the time and engine brake. So for that purpose, there is no real need to jump gears. But if you're cruising along the highway or something like that, you're in 9th gear, you're at 70 miles per hour, 1200 RPM, and this fast car is coming up against you or something. Then we have, you can shift up and down like you would expect with the gear level, 1 gear at a time. But then you have like an extra notch if you push hard, up or down, where the transmission controller calculates how big of a gear jump can I do right now without over revving or just killing the engine for too low RPM. And then it does that shift as quickly as to the next gear. So you can jump from 9th gear to 3rd gear, bam, like that. And that's more like a road thing. You wouldn't do that on a racetrack.
Absolutely.
And it's kind of a fun thing. You just slam it to bam, you go like that, and you shoot off.
So we like to set context here. So we've got opened up the engine bay, and this is what the gearbox looks like. I'm still wrapping my head around this is the gearbox. It's tiny.
It's kind of tiny.
It's really tiny, not kind of tiny, it's really small.
So normally you would have a flywheel and clutch between the engine and gearbox, but as the clutches are integrated into the transmission and kind of replaces the synchronizations, there is actually nothing there, and the flywheel effects more or less comes from the gears in the gearbox. So when you're in neutral and you're revving the engine with this super light crankshaft, you have virtually no flywheel. It's like an insane Formula 1 engine sound. But as soon as you connect everything, it settles down a little bit. But you get that's kind of a nice side feature. But yeah, you can see you have the starter motor integrated here. This is the starter ring for the starter motor inside the transmission. Here you have the final drive, and here we have carried over our limited slip differential from the Agera, and then you have the 3 axles going on in here. You have the solenoids acting and opening and closing the clutches for the gear sets. So we have 8 solenoids. 1 is for reverse, 6 are for the clutches driving the car forward, and 1 is for the electronic limited slip differential. Actually, this is kind of interesting. This part here is the differential area. That's actually the gearbox. And we have 2 different oiling systems, because when you have a crown wheel and pinion, like you can sort of envision it's here, you want slightly different oil characteristics than the gears and the clutches, especially when you have integrated clutches. So these clutch discs will slightly wear over time, and create a little bit of debris. So this side is much more filtered than this side has to be, because there are no clutches inside here. So and that means we can optimize the oil for like a rear axle oil more and more like a traditional transmission oil, and filter that a little bit harder.
How long does it take you to dream this stuff up, man?
It's not only me.
Bonkers.
It's not only me.
For sure, but it's just mind-blowing stuff.
So yeah, I mean, having been doing this for so many years, and having had to help develop transmissions for our crazy engine powers. I mean, we've always challenged the transmission manufacturers with our needs, and we've blown up a lot of transmissions in that process, and had to help to figure out the solutions. So we knew a little bit more about transmissions than we wanted to.
Sure.
And then we could use that experience to create this.
This is entirely your own.
It's entirely our own
design, made.
Absolutely.
Everything.
Yeah. Well, our own in the sense of Koenigsegg, not me personally.
Yeah, absolutely.
I've been part of it, but
I mean designed by Koenigsegg.
Absolutely, in-house. I'll show you upstairs where we do it. So.
I mean, this is a whole industry in itself, just this
kind
thing.
of. Yeah, kind of.
Right.
You can imagine, I mean, if you don't need 1500 Newton meters of torque, I mean, it's small for that, but if you're happy with 500-600 Newton meters, I mean, it could be super tiny and super light. And
that's interesting.
And I kind of see this as the successor of the DCT. I don't see any big advantage of the DCT when it's heavier and can do less.
Yeah, I mean, if this was a DCT, it'd be almost to where this exhaust is.
Right.
I mean, really, it's insane. It's really, really cool.
And it's about compounding gears and removing things we don't need by adding things that do more. That's the kind of philosophy.
Can you just sell this to the rest of the industry, please? Because this is wicked.
If they're interested, we're happy to help out.
Yeah, cool.
I'm sure they want to see it working first.
Yeah, I'm sure.
Because that's kind of what we always ask. What are we missing?
Cool theory, bro.
Yeah. So it seems so simple. I do expect through the development program we will keep on blowing up stuff.
I'm sure.
But usually we figure it out in the end.
Yeah. So that's actually a nice transition to talk about. Instead of opting for a smaller turbo to maintain boost and fill that lag, or a quad turbo or anything like that, you've maintained your two big turbos, but you've developed a system which is air injecting these turbos.
So we, in the process of developing this car, for what we envisioned that it needed to be capable of achieving, we needed bigger turbos one way or the other, and bigger than we had. And we investigated quad turbos and dual stage turbos or triple turbos and all this. And every solution seemed clumsy and heavy and difficult to package, and a lot of components and so on. So we thought to ourselves, what is the minimal packaging and weight we can have to achieve good response and a lot of boost with a lot of flow at high RPM? And after a lot of simulation and thinking, we came up with this idea, which is an evolution of what other people have tried before. For example, in Volvo diesel cars, you have an air injection system into the exhaust to spool up a quite small turbo. They have around 12 bar and a small tank. We have a big carbon fiber tank sitting at the back of the car with 20 bar, 20 liter, 20 bar, quite high pressure. And we have figured out ways of optimally injecting this into a big turbo setup. So and the thing with the big turbo is not only you have the inertia that you need to overcome, so that we can do very efficiently. So it just spools up like it's a tiny turbo by basically blowing at it. But a big turbo also has a problem of creating high pressure at low flows, at low engine RPMs, because it's more open. It kind of leaks around the blades more. So we're also using the air to seal off the turbo, so a big turbo can create higher pressure at lower flows than it normally can.
That's bonkers, man.
And the carbon fiber tank of 20 liters is only like 2 kilos, and then it's a small electrical pump, a few valves, and a few hoses and nozzles. So the weight compared to any other way of obtaining this characteristic is minimal.
Engine also not a facelift. You've gone for a flat plane crank.
Yeah, so first of all, I mean, we're running into seriously difficult emission regulations. So we had to redesign the cylinder heads from the ground up, for example. So we have a tumble valve in the intake port to make sure at low RPM And at cold start we get much more turbulence in the engine for better emission control at cold start, so we can meet these much higher emission regulations. We also made the cylinder head while we were at it lighter and stiffer, and integrated a secondary air system where we blow air into the exhaust to preheat the catalytic converter at cold start. And there we could piggyback off of our turbo boost system, because we already had pressurized air on board. So combining those two functions, it made it even lighter than having that and some other kind of turbo boost system. And then we have an electrically heated catalytic converter, so we can actually comply with all the regulations we see up until 2026. Wow. With this kind of combustion engine technology. So that's one thing. But from a performance perspective, we just spoke about the turbo system, of course. But then we have a completely new crankshaft, what we believe to be the world's lightest production V8 crankshaft at around 12 kilos. And the advantage of the 180-degree crankshaft is that it's lighter, so it spools. Well, the engine is more responsive, and you get more even pulsations for the exhaust, so the turbos are run a little bit more optimally. So it's about 40 horsepower free without any more stress to be had, which is a nice little bonus. And so what does this result in? Well, it results in a lighter engine, of course. It's about 15 kilos lighter overall, with the cylinder heads and the crank and the new connecting rods and pistons. We're up to 1280 horsepower on a regular 95 octane pump fuel, and in the US that means 91 octane. And on E85 we're up to 1600 horsepower. If you ever would need that.
1600 horsepower, wow.
Yes. There we have some great support from Michelin. The way our cars can put down power is just unique. And it has to do with our very long wishbones, our triplex suspension, and that we allow the car to squat a little bit during acceleration and out of the corners, so you can really sink that power into the ground.
But in terms of tyres, again, similar to the Rig era, these are tyres you can just order, they're not like a bespoke
exactly.
platform or anything.
No,
it's incredible you're able to get that performance out of something like that.
Exactly. We've been working with Michelin since we started production, and from time to time they have specially developed tires for us, but then they have put that into their original assortment, so you can just buy it over the shelf. And sometimes we've found tires that are suitable as they are, and we didn't have to do anything special. And in this case, that's what happened, as they had this Cup 2R support from the GT2 RS.
Yeah, I mean, in the past you set a public road land speed record, a Cup 2s, right?
Right, yes, yeah, exactly. They were standard Cup 2s, and they, I mean, when we went there to Nevada, Michelin was, I mean, we did a lot of pre-testing. We spun the tires and wheels up here to 510 kilometers per hour with everything inside, the wheel speed, pressure sensor, and Michelin did a lot of testing in their aeroplane test rigs for wheels, because nothing else was fast enough. And so we had a lot of confidence, but still Michelin said from their kind of previous experience that you probably have to change tire every other run, because they will heat up and
so much friction.
Exactly. And we put in infrared sensors in the car to scan the tires while driving to check the temperature, and it was less than half than expected. And after a couple of runs, Michelin looked at the tires. No, you can run all day with these.
Wow, amazing.
So that was pretty shocking.
So on this car, am I right in thinking that you've added a similar triplex setup in the front?
Yeah. So
because of the
exactly. Now
downforce?
I see the triplex in the rear is out, but for this car we have a slightly different need, as the downforce is over 880 kilos at 250 kilometers per hour. And 1,000 kilo at 270 kilometers per hour in track mode. We need to basically have a very progressive spring ratio setup and a very advanced damping system that changes damping characteristics for these different modes. Basically, from normal to track, we're more than doubling the downforce. And how do you make a suspension system that behaves good in both conditions? So we're basically putting a triplex here in the front as well for the first time, but we're also adding a helper spring and a track spring that comes into play when you're lower, and a hydraulic lifting system, and active bump and rebound damping.
All in one unit?
Yes. And then you have the normal dampers down below, which also have active bump and rebound and ride height. And the same setup goes in the rear. So instead of just having a passive triplex damper, it's an active track spring, active bump and rebound as well, to keep the car level with these massive amounts of downforce without being too stiff. what this means, this is the track-focused version of the JESKO, but what that means is we can't slip in the roof here anymore, and there is actually a big air scoop here going out through the bonnet, which gives a lot of downforce and cooling.
Right.
But we're making a lower drag version as well.
Okay.
Where we don't need this system to hold the car up because it's lower downforce and lower drag, and then we can still store the roof, and it's still, I mean, we're still talking 300-400 kilos of downforce. So, and the rest of the car, apart from the aero, will be the same. So it will still be an amazing track car. But in that car, we're putting in the option of having like memory seats and a few more creature comforts, and theoretically with that aero package, the car can do over 300 miles per hour.
Let's talk about this wing.
Yes, yes. It is huge, and I think it's kind of a nice, simple shape to it. And so why is it so curved? Two reasons. There are regulations for road cars that are different from different markets, and we're complying with world market regulations. So this is a car homologated for US, Europe, Asia, Middle East, everywhere. We have smart airbags, we have everything on board. And actually that's, when comparing kind of lap times and so on, that's the kind of cars we should be compared to.
Sure.
And we believe this car will be the fastest worldwide homologated car on big tracks like Silverstone or Nürburgring or Spa. There will be probably some other cars like, for example, the Valkyrie that will be faster, but as far as I'm aware, it doesn't have like worldwide homologation.
Right. Okay.
Which makes our car heavier because we need to have 4 airbags, we need more crash elements and these things.
Yeah.
So one should compare apples to apples when it comes to those things from our point of view.
Sure.
But so it also meant we're not allowed to stick the wing out outside of the car. So it had to kind of follow the curvature of the car. So that's why it's bent. That doesn't give any more downforce, that shape. It's just we have to follow that shape.
Sure.
But there is an advantage. And since the wing is not allowed to be wider than this, when you bend it, you actually get more wing surface for the width.
Greater surface area.
Exactly. So there is an upside anyway. And
I
also
love how every one of your components has a reason, there's a story, or even when you've developed something for one reason, then you end up finding like 3 benefits.
I mean, that's always the fun hunt for things. I mean, how do you make a car lighter or more interesting or / better or whatever? It's finding those opportunities along the way. Hey, let's combine these 2 things and throw this away.
Sure.
Hey, do we really need this? Or can we drill a hole here to make it lighter? Or, we bend it and we can have this extra shape here. Those things is what makes the car do what it can do in the end. And that's what I'm excited about, like finding those little extra opportunities beyond the obvious. So we pioneered the carbon fiber wheel for a production car in 2011. And our, let's say, competitors or fellow sports car manufacturers, they said, hey, you can't do that. We kind of tried that 10 years ago, it didn't work, and this and that. And then I said, well, we've tried this now for 3 years on racetracks and came up with the special curing process and special epoxies to take the heat and this and that, so it works. And they were very, very skeptical. Now they all do it. Cool. 7-8 years later. But they still don't do it our way. We're the only ones who have this hollow core technology, so it's all empty inside here, and we have a patent for that. 13-inch wide, weighs 7.4 kilos, so you can pick it up and see it's crazy. And it's the lightest wheel we've ever made.
Is absurd.
Regardless of size, and that has to do with the design. So the front wheels are 5.9 and this is 7.4. I
know it's really hard to convey things like weight on video.
Right.
But if any of you guys have picked up an alloy wheel before, you're not doing that in a hurry. That's unbelievable.
It is.
Wow.
And what is also quite interesting is we're the only ones who make carbon fiber wheels with no metal inserts. If you look around here, you find no metal.
It's just pure carbon.
It's just pure hollow carbon. You can see through there, you can see the hollowness inside the spoke. And it's just carbon.
It's very interesting being here pre-Geneva. Talk us through how the body panels go on the car. Because
exactly.
You've got this interesting new sort of seal, right?
So we normally have huge clamshells on all our cars up until now. And this still has a very big clamshell in the rear, even though it's slightly smaller. But these things are very cumbersome to handle in production, and if you have a damage, you kind of damage the whole part,
Yes.
which can be the whole rear of the car. It's very expensive to repair, and we thought, is there a kind of a more clever way of doing this? And we managed to get away with one part, as this quarter panel, it reaches all the way to the center, and there's a split here. So if you damage this quarter panel here, or let's say the bumper here, you're not damaging the bumper over here. Sure. It's a separate part, and these are more like human-sized parts to handle in a manual production than these enormous big things you might.
Piece clamps,
Exactly. Still, of course, it brings drama to the car to have these clamps. So in the rear, it's not mounted right now, but we can actually see here. That's interesting. This is half of the rear clamp. It's also split in two.
Yeah. Wow.
So it becomes a big, massive part with that kind of exoskeleton underneath.
Yes.
And this enables us to mount a lot of the hydraulics and electronics into this piece without having to be super careful about painted parts. And then we put the painted parts on top, and it becomes a big clamshell, but the parts are much more manageable for a human. So we did kind of a few of those things for this car to play around with an experiment, and yeah, it's turned out good so far. It also gives this kind of interesting feature of something running through the car. We picked it up in the center console. You can see it's running through the car there, and we also took the opportunity to enlarge the monocoque. So the monocoque is 40 millimeters longer, so it's a little bit easier to get in and out. And we also raised the roof a little bit and made the glass a little bit higher. So you have a little bit more space and a little bit more visibility inside the car.
So with the car being slightly longer, you've also introduced rear wheel steer.
Correct, yeah.
This is the first time?
First time ever, yeah,
Koenigsegg?
exactly. Okay. So due to that, the monocoque is 40 millimeter longer, the wheelbase is 40 millimeter longer as well. So we have a 2,700 millimeter wheelbase instead of 2,660. So we already had a quite good turning circle on our cars, but to make sure we could improve on that, even though we have a longer wheelbase, we introduced rear wheel steering. And also, we already had fantastic high-speed stability with the 2,660 wheelbase, as we could see in Nevada. But this will even further enhance that, and as a version of this is potentially even faster, why not?
Why not?
So that's the reason for that. But apart from that, we kind of kept our geometries and very long wishbones intact, refined these over the years. So we have such a nice combination of traction and stability and tire wear, and we didn't want to change too much there. But we kind of moved around things a little bit so that we can have a similar geometry but with a lower ride height. So that's basically the only difference there. We had this opportunity space up here, so we decided to put the most analog thing imaginable in the face of the driver, and it's powered by just G-force. It's just super smooth ball bearings with weights down below. So you have a bezel with a weight, and then you have like a marker, and then markings on this. So when you turn, the weight turns that direction, and then you get a readout. And then you have a rotating disc in the other direction with the ball bearing with the weight down low, and that starts spinning in this direction with arrows and markers. So it's fun. It's kind of powered and moves with no apparent input of energy, apart from what the car puts into it. And there is no like math or calculation or computer or even hardly any mechanics. It's just weight and ball bearings. And it's just a fun way of showing how you can make something interesting with almost nothing.
And that's quite nicely contrasted with your new wheel, which has a sort of digitally floating instrument cluster.
Yes, when you turn the steering wheel, I mean the screen is small as it's on the steering wheel, but it's close to you, so you get a good visibility anyway. And the great thing is when you're here with your hands, you would normally block your instrumentation, but here it's fully visible. I mean, even there you can see it. And it's still, it's self-leveling.
So if you're familiar with the Rolls-Royce logo in the middle of a Rolls-Royce wheel, they're always stable. It's like the digital equivalent of that on your instrument cluster.
You could say that, absolutely.
Kind of.
Yeah, absolutely. And then we have changed our mechanical buttons and scrollers into haptic touch screens. So you can slide and scroll around, and when you choose something, it like on a modern phone. And we can over the air upgrade all of these features when we come up with new ideas. So instead of being locked in with a a machine button with some kind of symbol on it, and that's it. We can maybe it makes more sense moving this around here, or when you press here, the whole thing goes red and does this, or whatever we come up with over time. It gives that huge flexibility of adding features over time.
So if I don't get to show it to you today, it'll be on the stand at Geneva, and I'll make sure I show it to you.
So here we have 7-8 guys polishing carbon parts, aluminium parts before and after surface treatment. So we get them in a raw machine, and then when they're polished, we package them into these kind of crates, and then we send them away for example, for DLC coating.
Oh, wow.
These are pedal box here.
So this is your pedal box.
Yeah. So normally I should have white gloves here, so I shouldn't touch this, but.
That's just insanely beautiful.
One of the pedals.
I mean, so your storage boxes are more glamorous than most high-end watches.
Right.
Wow.
And let's see if we find something else interesting in here. This is a set for a car.
Okay.
So here we have buttons.
Oh, look at that.
And with the ghost holes, laser-edged holes, and the center console.
Wow. Oh, it's stunning. Absolutely stunning.
So it goes several hundred hours into each car just polishing parts.
Just polishing.
So here we're polishing a whole monocoque. And here you can see the example of the K&C, the Koenigsegg Naked Carbon, which we started making whole cars out of. So I will bring out a part.
Sure. It's nuts. Absolutely nuts.
So there's a thin layer of epoxy over the carbon that naturally forms there. It's like a couple of mu thick. And normally what we do and others do, we just polish this up to a shine or clear coat it. And whether you polish this to a shine or clear coat, you kind of get the same effect. There's like a lacquer layer, in this case epoxy. But here we grind away that thin layer, and you can see in the crimping between the carbon, you see a little bit dark spots. That's epoxy, but these strands, they're more or less 90% carbon.
Wow.
And when you touch it, it's colder because carbon is more like a metal thing than a plastic thing, and it's very strong for scratch resistant. And you get this kind of metallic sheen in comparison.
Yeah.
But you have to be so careful because, of course, what you see is the first layer. Right. And if you don't grind enough, you will have like a puddle mark of epoxy. And if you grind too much, you will start seeing the next layer in a different direction. Man. So you just have to like very carefully grind.
No pressure at all then.
That's why hardly anyone does this, because it's like a little bit too little or too much, you're screwed and you have to scrap the part.
And you do this on an entire car?
On an entire car.
Entire car.
So we're showcasing at Geneva a customer's car, which is completely K&C, Koenigsegg Naked Carbon. So we say naked instead of clear. This would be clear carbon, but that's naked because we tear off the epoxy clothing.
Honestly, man.
By careful
every room I'm getting my brain rewired. The details are amazing.
Just a different luster.
It has a very different finish. Really interesting that you should explain why your carbon looks like that, because your carbon does have its own
sheen.
It's got its own feel about it. I've never seen it anywhere else.
Yeah, so we've been doing this on smaller parts for 4 or 5 years, but then we got challenged, and of course when you do the whole outside, you can't fill anything, smooth out anything, and even if you clear coat a car, if you have a slight imperfection, you can fill a little bit more clear coat and then flatten it. Here, when it's naked, it's naked.
And that's it.
And it means that if you look like along the bodywork, you might see a tiny little ripple somewhere, like a little ripple. But when you think about it, that's just straight out of the tool and nothing can be done to it. It's kind of even more amazing only with a tiny little ripple.
Yeah.
So, and of course you say, wait, when you're finished with a high-end painted car, I mean, we put on like 7 times a clear coat and flatten it, and more clear coat and flatten. In the end, you end up with like 150 mu of clear coat. When the normal car, you have maybe 30, 40 mu, and that's just to get that depth and shine. And if you have a scratch, you can buff it out and so on. But by just ignoring that whole process and doing naked carbon, it's about a 20 kilo weight saving.
Oh, that much?
First of all, we grind away maybe a kilo of epoxy, and then we don't add the 19 kilos of paint.
Wow. Yeah.
So
he's on another level, isn't he, this lad?
And here we can see this is an early prototype Agera, the first carbon fiber wheel we made. And here you can see a cut through This is just an ugly sample, but you can see a cut through of the hollowness. Here you have the central
hollow spokes,
and you can see the layup of the fibers and how it's thick here and it goes thinner, goes a little bit thicker, very thin, thicker here, thinner and thicker. So you optimize it throughout the shape in a hollow way as well. And you can see it's pretty massive here in the center, of course.
Someone's laying this up by hand.
Yeah, they're doing it in here. So, lay in the right stacked order, and this is how it's done. This is with the core material that we then diffuse from the center. So we lay up carbon onto this, it expands, pushes it out, and then it contracts, and then we take it out.
How do you take it out?
That's the secret.
I was gonna say, cool. Keep it that way. Some more mind-blowing stuff over my shoulder is an example of these guys designing and building the wiring looms in-house. Over 2.5 kilometers of wires in each wiring loom for each car, and they do it all here. It's unreal. It's really crazy stuff. So as I mentioned at the beginning, really unique look at Koenigsegg getting prepped for the Geneva show. Thanks so much for showing us and for giving us such an early look at the car. Next time you see this car on my channel, it will be at Geneva and completed, so we'll see what it looks like in all its glory, and you'll be fighting off a lot of press. So
I guess.
Best of luck with that, because it'll be an intense one. Really appreciate it.
Well, thank you so much for coming.
Nah, pleasure, man, and congratulations on the car.
Thank you so much.
Thanks a lot.